Okay, we're going to go over the worksheet that we did in class for the standard deviations and variances. So right here we have a sample of employees that Mr. Kent has hired for his his Clark's Comics and Collectibles shop. You see here on the left-hand side, we have the employees and what kind of variable, what level of variable are the employees. And if you said nominal, you would be correct. And we have the age of the employees. What would that be? If you said ratio, that would be correct. Birthday, what would that be? That would be interval. Badge color would be nominal. Position would be ordinal. Years, this is years worked. This would be ratio. And then pay rate finally would be ratio. Okay, first of all, it's important to determine what you can calculate a standard deviation for and what you can't calculate a standard deviation. If you can calculate a mean, you can calculate a standard deviation. Okay, so can you calculate a mean for nominal data? The answer is no, so we're going to put a red mark right there. What about for ratio data? You can. Okay, so we're going to equals average. Okay. And then the average is 21, or the mean. Birthday, can you get the mean? The answer is yes, you can. So the question is what is the mean? So the mean is the way that you average birthdays, or dates, if you will, is you find the distance from AD, 0 AD, and then you average those distances from 0 AD, which in this case it's 35,492 days from 0 AD, 0.1667. So, and then we can put that in date format. Let's see here. Date format. What about badge color? We can't do that. We also can't get a mean for ordinal data, so we'll put a red one right there. Years, can we get a mean? And the answer is yes. So we're going to put an average, or you can add all of them up and divide it by the total number. Okay, so right there we have 4. And then pay rate equals average. Okay, so in order to find a standard deviation, we need to first find the deviation from the mean. So what we really need to do first, though, is determine what is a standard deviation. Okay, a standard deviation is essentially the average distance of the data points from the mean. Okay, so in a normal distribution, this is a normal distribution right here, 68% of individuals fall in this area right here. Okay, between these two lines. But if you average everyone, that is positive, okay, so if you average all of the individuals and their data points, the average is going to be right here, or mu. This is the population, okay? So this is the average or the mean. But if you average the distance that they are from the mean, then this would be the distance, the average distance from the mean, right here and right here. These are both equal distant from the mean. Okay, so I'm going to put this back right here. So the mean is 13. So we're going to put 13, 13, 13. Okay. and then we are going to subtract the mean from the we're going to subtract the mean from x. So you've got x bar right here, and you've got x right here. So equals 9 minus 13, and that gives us negative 4. And then if you just drag it down, 15 minus 13 gives us 2. 10 minus 13 gives us negative 3. 11 minus 13 gives us negative 2. 18 minus 13 gives us 5, and 15 minus 13 gives us 2. Now, a way to check all of this is you want to check to see if the deviations from x, if the sum of the deviations from x equals 0. So you equal sum. Okay, the sums of the deviations from x should always equal 0, because basically you're asking how far away do all of these deviate from x, and if all of those statistics give you, or rather if all of those data points give you the mean, then they should all add up to 0. Okay, so we've got deviations from x, and then in order to put them in absolute, or sorry, in order to get them all positive, we need to square them. So equals squared 16, 4, 9, 4, 25, and 4. And then we've got to take a sum of all of these, and the sum of all of these equals 62. Now, here is the next point that a lot of people get tripped up on. You are either going to divide it by n, or you are going to divide it by n minus 1 in order to be able to get the variance. Okay? N or n minus 1. And you divide it by n if you're working with a population, or you divide it by n minus 1 if you're working with just a sample. So, are we working with a sample, or are we working with a population here? And you see right here, he hired 15 employees and recorded pertinent information about them. Do we have 15 employees here? We don't have 15 employees here. We only have 6 employees here. So what we need to do is divide it by n minus 1. N is the total number of observations we have. We have a total of 6 observations. So we need to do 62 divided by n minus 1, or 62 divided by 5. So equals divided by 5, and that right there, 12.4, is our variance. Now the variance really doesn't tell us anything, and you know, it really is just another step on the way to getting to the standard deviation. The standard deviation is literally only the square root of the variance. You don't have to do anything else, whether it's for population or whether it's for the sample, because the variance accounts for the population and the sample. All that you've got to do is take the square root of the variance. So equals square root. Okay, so 3.52. Okay, 3.52 is the standard deviation. Now, what this looks like is we are now going to generalize the results to a larger population. So we've got the sample of 15 employees, and we want to know, based on these 5 employees, can we generalize this to a larger population? Okay, so what is the mean? First of all, we need to record the mean right here. Let's see here. Home, we'll put... The mean is 13. Okay, so the mean is 13. And then in order to find out the standard the rest of the standard deviations, we need to either add 3.52 or subtract 3.52. Okay, so I'm going to actually put this right here. So equals this minus 3.52. This is 1 standard deviation below. This is 2, and this is 3. So we have now, let's back this up right here. 3 standard deviations below the mean is 2.44. And then this is 2 standard deviations below is 5.96. Oops. 1 standard deviation below is 9.48. Okay, then we need to look at the standard deviations above the mean. So equals this, equals the mean plus the standard deviation, 3.52. So 16.52 is 1 standard deviation above, 20.04 is 2, and 23.56 is 3. So let's put those in. 16.52. And then we've got 20.04. And then we've got 23.56. So let's take a few minutes and just look at what this all means. Now, something else that's really important is on your worksheet that I gave you, you'll notice that this right here, we've got the population formulas to do the standard, to put the standard deviations on the normal distribution. And then we also have the sample formulas to put the standard deviations on the normal distributions. So right here we have put the population, or sorry, we have put the sample standard deviations onto the normal distribution. So based on this information, 68% of the individuals that work at the comic book store should fall within the 9.48 to 16.52. Okay, so there's a total of 15 employees. So 15 equals 15 times 0.68. So 10.2, or about 10 employees would work within this area. Okay, within the 68%. Okay, so we've got 95%, or about 14 people would be within 2 standard deviations. Okay, 2 standard deviations. So that means between 5.96, they would be getting paid between $5.96 and $20.04. Now, if I were to ask you how many people get paid less than $20.04, then what we'd need to do is look at, okay, so 95% get paid less than $20.04. But what about, let's do this. I want to brush. What about this area right here? So you get 95 plus whatever else is in this area right here. So the entire normal distribution is comprised of 100%. So if it's 95% that's in here, there's about 5% left, or there's 2.5% left over here, and 2.5% left over here. So you would have to do 95 plus 2.5, which would give you anything less than 20.04. Let's see if we can do this. Anything from here over, I don't like that, sorry. Anything from here going that way would be 95 or 97.5%. Now, something that's really important to know about a distribution, a normal distribution like this, is technically this goes on to infinity. Okay, so you see 99.7, and the further you go out, it's going to get to 99.8, 99.9, so on and so forth, but it will never hit 100% because theoretically this distribution goes on for infinity. Okay. So let's go back over here for a minute to the worksheet. Down here, I have given you the ability to work out the ages and also work out the ratio or the years that they have been employed. So you can work on that on your own time and just practice it. Make sure that you know what you're doing. And practice calculating the variance and the standard deviation. Also, another way to do it, if you prefer to work it out as an equation, on your equation sheet, let me pull up the equation sheet really quick. Okay, so on the formula sheet, I have the sample population and the sample variance. If you wanted to, you could do the formula as such. Let me show you how to do this really quick. I'm going to go into Word. Another way that you can do pretty much the exact same thing, you can put in the data points into the actual equation. And so you see the equation right down here. The equation is this is the variance equation, the equation for the sample variance. And it's saying sum the occurrences of x minus the mean squared. So we have right here 9 minus 13 squared, 9 minus 13, which gives us -4, and then we square that, which gives us this. Okay, and so this right here is the equivalence of 16. 15 minus 13, so 15 minus 13, which gives us 2 squared, 4, and so on and so forth. Okay, so I just typed out what those results would be with 16, 4, 9, 4, 25, and 4, divided by 6 minus 1 in this case because it's a sample, which gives you the variance being variance 12.4. And then if you were to take the square root of that, it would give you the standard deviation. Now in the future, it's a lot easier. I'm going to show you guys how to check your answers. Equals standard deviation. You put equals STD, EV, and then if it's the population, you do .p, or if it's the sample, you do .s. So in this case, it's a sample, and we're going to do pay rate. And you'll notice the standard deviation, this is the same. Or if you do equals VAR, P, but you notice this is the variance of the population. This right here is the variance of the sample. So if I do .s, that gives me the variance of the sample. Okay. So that is how you check your variance and your standard deviation. And in the future, you're not going to have to do all this by hand, but we do it by hand now to make sure that you know exactly what it is that you're doing. Hope this was a beneficial exercise. I will upload this for you so that way you can also practice on the rest of the data set as well. Thanks.